All right, so hi once again, everyone. We continue our study of Chapter 12, Vectors in the Geometry of Space. Really, we're not getting into the Calculus 3 material yet. We just have to have a good understanding of how vectors and space geometry works before we can really get into the calculus. So in section 12.4, we're talking about the cross product. In section 12.3, we talked about the dot product. So there are two different types of vector multiplication. The first was the dot product in section 12.3, which, remember, that was the result of that was actually a scalar, not a vector. That scalar did allow us to have some geometric interpretation as far as getting the angle between two vectors. The cross product is another type of vector multiplication. However, this time the result is a vector. So if I have two vectors u and v with three components each, if I take the cross product, so this time symbol now, from now on when we're working with vectors, the time symbol means cross product. The dot was the dot product. So this is read as u cross v equals the length of the vector u times the length of the vector v times the sine of theta, the angle in between the two vectors. And then that is the scalar component times the vector n, where n is a unit vector that is normal. So in Calc 3, we start to use the word normal to mean perpendicular. So sometimes orthogonal is also used. So normal, orthogonal, or perpendicular are all the same meaning. It's both u and v in the direction determined by the right-hand rule. So the way you determine which way the cross product goes is, it's first of all, it's going to be perpendicular. It has a 90-degree angle with both u and v, and you can see that in the picture. And then, well, the question is then, is it up or down out of that plane? So the way you determine it is your fingers point in the direction of u and they curl towards v. And then wherever your thumb is, that's the direction of u cross v. So to compute the cross product, we actually have a mnemonic device that we're going to use. It's a determinant formula if you've had linear algebra, which I know not everyone has had. So think of it as a mnemonic device. U cross v. So it's this 3 by 3 determinant where these absolute value looking lines mean determinant if you had linear algebra. So don't worry about it. Again, just a mnemonic device, a memory aid. The first row, we write the vectors I, j, k. The second row, we write the vector u, whichever one is first in u cross v. So u1, u2, u3, the components of u. And the third row, we write the vectors, the components of v, v1, v2, v3. So the way you remember this looks like an ugly formula, but the way you remember it is, so if you want to see what's multiplied times the vector I, you forget the column below I and to the right of I. So it's this 2 by 2 determinant. You can see that right here. And 2 by 2 determinants are determined by multiplying the main diagonal this way. You can see this arrow. Multiplying u2 times v3 and then subtracting the off diagonal, v2 times u3. So it's u2 v3 minus v2 u3, whatever that comes out to be, and that's the scalar component of the vector I. Then we have to remember to put a minus sign in front of the scalar component for j. So when you put a minus sign, you just have to remember that there's a minus sign there. So how do I determine the 2 by 2 determinant here? So it's the column under j is gone and the row of j is gone. So it's u1, u3, v1, v3. And then you compute the 2 by 2 the same way. u1, v3 minus v1, u3. So that's that. Just remember there's a minus sign in front of it. Plus, now this one's plus. So for k, it's this 2 by 2 determinant. So it's u1 v2 minus v1 u2. So once you do that a couple times, it turns out to be pretty easy to remember. It's just that first couple times you have to understand how that works. So for example, here's a vector u, which is 2i plus j plus k, and a vector v, which is minus 4i plus 3j plus k. We want to find u cross v and v cross u. So u cross v means you write the components of u in the second row here, right? I, j, k always in the first row. So 2, 1, and 1 for 2i plus j plus k, and the components of v in the third row. So minus 4, 3, 1 for minus 4i plus 3j plus k. Then For the I, what's multiplied by I is it's this 2 by 2 determinant, 1, 1, 3, 1. So it's 1 times 1 minus 3 times 1. 1 minus 3, minus 2i. Remember, you need a minus sign in front of the scalar for j. So the 2 by 2 for j is this 2, this 1, right? Not the column under j. So 2, 1, minus 4, 1. So it's 2 times 1 is 2 minus 4 times 1. So 2 minus a minus 4 is 6. But with a minus sign in front of it, it becomes minus 6. And then for the k, it's this 2 by 2. 2, 1, minus 4, 3. So 6 minus a minus 4 is 10. So that's plus 10k. Or in component form, we could write it as with triangular braces, minus 2, minus 6, 10. So I'll leave it to you to work through v cross u. It just means that you put the v in the second row and the u in the third row, and you run through it the same way. So I is 3 minus 1, right? So there's 2i, etc. What I want you to notice is that u cross v is actually the opposite of v cross u, or vice versa. And that's actually our second property on the next page.